First of all, I would like to introduce myself. I'm Liu from the Department of Biomedical Engineering. I'm going to handle the first 6 weeks of this course for Group 2, and Dr. Anida will be handling the rest of the weeks. Since today is the first day, we'll go through something light, which include the concepts and principles of engineering economy. Before this, let's take a look at how you will be evaluated in this course. You will be given one assignment which carry 50 marks, one test which carry 20 marks, several class tutorials or pop quizzes which carry 5 marks, and one final exam which carries 60 marks. And this final exam normally consists of 4 questions. Let's take a look at what is economics. Economics is the study of the use of scarce resources to satisfy unlimited human wants. It is the study of how people seek to satisfy their needs and wants by making choices. It is about solving the problems of scarcity. And what is scarcity? Scarcity is the conditions in which our wants are greater than our limited resources. All goods and services we produce are scarce. Scarcity implies quantities of resources to meet unlimited wants. Scarcity always exists because our needs and wants are always greater than our resources can supply. May I ask you, is shortage same as scarcity? Scarcity of a resource implies natural limitations of a resource. Shortage is not the same as scarcity. A shortage is a temporary situation and man-made unavailability. It occurs when a supplier cannot or will not offer goods or services at current prices. The basic economic problem arises because resources are scarce, but human wants are unlimited. To fulfill human wants, we need production. Production's capacity is limited due to limited resources. Land, capital, and labors are the resources for the productions of goods and services. And land is used to refer to all natural resources which are used to produce goods and services. The natural resources are found in nature, for example, the land, water, trees, coals, and etc. Capital, on the other hand, is the investment money used to produce other goods and services. And labor is the effort that a person devotes to a task for which he is paid for. Labor is the workforce for productions of goods and services. For example, the doctor services, factory and assembly line workers, retail salespeople, mechanics, and etc. These are considered the workforce. The size of the workforce pretty much depends on the scale of the operations in the company. The education level and the quality and the work ethics of the workforce very much affects the production's capacity. Productions can also be limited due to limitations in the state of the current technical knowledge. The use of advanced technical knowledge, for example, the use of robotic arm in the automobile industry, can increase the productions of vehicles. What economic comprises? Economic comprises of a set of scarce resources capable of producing a finite quantity of goods and services. These resources include workers, machines, factories, raw materials, and etc. A population with effectively unlimited wants. People have limited amount of money, yet they have lots of needs and wants to satisfy. For example, spend the money for shoppings, DVDs, holidays, and etc. Also, the government has a limited amount of money. It is unable to satisfy all its wants. How would the government budget the money for schooling, for national health, for police, for the military, and etc.? Economy therefore also comprises of the social mechanism that allocates the resources among their competing possible users. The functions of economy is to allocate scarce resources among unlimited ones. Here are the basic concepts of economy. What is wants? Wants is our desire to have something not essential for us to survive. For example, the chance to go for a movie, the wants to get latest accessories, and so on. Needs, on the other hand, is the best or other basic requirements for survival, like food, water, and shelter. Scarcity, as I mentioned, are the limited quantities of resources to meet unlimited wants. And the factor of productions are the scarce resources that are used in the productions of goods. Here are the factors of productions. Land includes the gifts of nature or natural resources on the planet not created by human effort. It includes space on the ground, hills, oceans, air, forests, and etc. Capital is the investment money and also man-made physical goods used to produce other goods and services. These include tools, equipment, and factories used in productions. Labor includes people with all their efforts and ability. It is a human input into the production process. Each individual has a different level of skills, qualities, and qualifications. Labor is also known as human capital. Entrepreneurs are individuals who provide the initial ideas. They risk their own resources to start a new business ventures or bring a product to market. They also organize the other three factors of productions. There are three basic economic equations on allocations of resources. This is about how resources are allocated between competing users. Any individual, organizations, or nations has to make three fundamental types of choices about how to allocate the scarce resources available to it. It has to decide what goods and services will be produced. For example, whether to produce food or industrial machinery, whether to produce books or newspapers, and so on. How will goods and services be produced? For example, how many workers will be used, and with what machinery? For whom will goods and services be produced? Will some people get a bigger share of resources than others? Will some people get so few resources that they cannot survive, while others live in luxury? How does an economy work? Economy works by having decision makers make choices based on certain working mechanism. Since we are unable to have everything we desire, we must make choices on how we will use our resources. In economics, we study the choices of individuals, firms, and governments. Here shows the working mechanism of the economy. Common economy, also called centrally planned economy, is one where all economic decisions are made by the government. The government decides what to produce, how it is to be produced, and how it is to be allocated to consumers. This involves a great deal of planning. Planned economies tend to be run by governments through command mechanism, or what we call the instructions of the ruling body. The government wants to see a greater economic equality between consumers. Goods and services should be produced to satisfy the needs of all the citizens of a country, not just those who have the money to pay for goods. Market economy Also called free market economy, is one where decisions are made through market mechanism. The forces of demand and supply determine how resources are allocated without any interference from the government. What to produce is decided upon by the level of profitability for a particular product. In other words, buyers cast their spending votes in the marketplace. Production is organized based on what is most profitable. Firms are encouraged to adopt the most efficient methods of production. Okay, may I ask, for whom production should take place? Okay, the answer is production is normally allocated to those who can afford to pay. Consumers with no money cannot afford to buy anything. Okay, we also have mixed economy. Mixed economy is the economy where some goods and services are produced by the government and others are produced in the free market sector, okay, which means it's a mixture of a pure command economy and a pure free market economy. Some resources are allocated via the market mechanism and some via this command mechanism. A mixed economic system protects private property and allows a level of economic freedom in the use of capital, but also allows for governments to interfere in economic activities in order to achieve social aims, for example, in international trade and in transportation. There are two branches of economics. Macroeconomics is the branch of economics that is concerned with the behavior of individual economic entities, such as individuals, households, firms, market, and industries. For example, how individual prices of goods are set in the competitive markets, how prices of labor are set in the labor markets, inquiries into the strengths and weaknesses of the market mechanism, personal decision-making, and etc. Macroeconomics, on the other hand, is the branch of economics that is concerned with the overall performance of the economy. For example, the national economic growth, government spending, inflation, studies of the effect of unemployment, and etc. In the 1940s, engineers mainly concerned with design, constructions, and operations of machines, structures, and processes. Very seldom they give attention to the resources. Nowadays, engineers are expected to generate novel technological solutions and also to make skillful financial analysis of the effect of implementations. We are expected to answer the basic economic questions of any design, which is, does X benefits exceed X cost? In today's close and tangled relationship among industry, the public and government, cost and value analysis are supposed to be more detailed and inclusive. Without this analysis, an entire project can be a burden than a profit. Inherent to the engineer's decisions are trade-offs amongst different types of cost and the performance provided by the proposed design or problem solutions in terms of response time, safety, weight, reliability, and etc. The missions of engineering economy is to balance these trade-offs in the most economical way. For example, if an engineer at Ford Motor Company invents a new transmission lubricant that increases fuel mileage by 10% and extends the life of the transmission by 30,000 miles, how much can the company afford to spend to implement this invention? For this, engineering economy can provide an answer. In this study, the economic aspects of engineering are emphasized apart from the technical or physical aspects. Clearly, it is essential that the economic part of engineering practice be accomplished well. Thus, engineers use knowledge to find new ways of doing things economically. Engineering economy involves the systematic evaluations of the economic merits of the proposed solutions to the engineering problems. To be economically acceptable, the solutions to engineering problems must demonstrate a positive balance of long-term benefits over long-term costs, and they must also promote the well-being and survival of an organization, embody creative and innovative technology and ideals, permit identifications and scrutiny of the estimated outcomes, and translate profitability to the bottom line through a valid and acceptable measure of merit. Engineering economic analysis can play a role in many types of situations. For example, in choosing the best design for a high-efficiency gas furnace, in selecting the most suitable robot for welding operations on an automotive assembly line, in making a recommendations about whether jet airplanes for an overnight delivery service should be purchased or leased, and in determining the optimal staffing plan for a computer help desk. From these illustrations, it should be obvious that engineering economy also includes significant technical considerations. In other words, engineering economy involves technical analysis with emphasis on the economic aspect and has the objective of assisting decision making. The foundations for engineering economy are a set of principles that provide a comprehensive doctrine for developing the methodology. These principles will be mastered by you when you progress through this course. Once a problem or need has been clearly defined, the foundations of the engineering discipline can be discussed in terms of these 7 principles. These principles include: develop the alternatives, focus on the differences, use a consistent viewpoint, use a common unit of measure, consider all relevant criteria, make uncertainty explicit, and revisit your decisions. We'll look at each of these principles in the next few slides. Principle 1 is about developing the alternatives. But before we develop the alternatives, we have to first carefully define the problem. Then we have a decision situations involves making a choice among 2 or more alternatives to solve the problem. Developing and defining the alternatives for detailed evaluations is important, as this will impact the quality of your decision. Engineers and managers should place a high priority on this responsibility. Creativity and innovations are essential to the process of developing the alternatives. One alternative that may be feasible as a decision is making no changes at all, which means doing nothing. If you judge this option feasible, make sure it is considered in the analysis. Principle 2 is focus on the differences. If all prospective outcomes of the feasible alternatives were exactly the same, there would be no basis or need for comparison. We could just make a decision using a random selection. Obviously, only the differences in the future outcomes between the alternatives are important. Outcomes that are common or the same to all alternatives can be disregarded in the comparison and decision. For example, if your feasible housing alternatives were 2 houses with the same price would be inconsequential to your final decision. Instead, the decision would depend on other factors such as locations and the annual maintenance expenses. This example emphasizes the basic purpose of an engineering economic analysis, that this is to recommend a decision or future course of action based on the differences among feasible alternatives. Principle 3 is to use a consistent viewpoint. It is important that the viewpoint for particular decisions be first defined and then used consistently in the descriptions, analysis, and comparisons of the alternatives. For example, consider a public organization operating for the purpose of developing a river basin. The organization is tasked to generate and wholesale distribute electricity from the dams on the river system. A program is being planned to upgrade and increase the capacity of the power generators at two sites. What perspective should be used in defining the technical alternatives for the program? The decision makers is the owners of the firm. Who is the owners of the firm? Okay, the owners of the firm in this example means the segment of the public that will pay the cost of the program, and therefore their viewpoint should be adopted in this situation. Okay, now let us take a look at another example where the viewpoint may not be from the owners of the firm. Okay, suppose a private firm is dealing with the problem of providing a flexible benefits package for its employees. Also, assume that the feasible alternatives for implementing the plan all have the same future cost to the company. The alternatives, however, have differences from the perspective of the employees, and their satisfaction is an important decision criterion. The viewpoint for the analysis should therefore be from the employees as a group, and the feasible alternatives should be defined from their perspective, rather than defined from the perspective of the owners of the firm. Principle 4 is use a common unit of measure. Using a common unit of measurement to enumerate as many of the prospective outcomes as possible will make easier the analysis and comparison of the alternatives. It is desirable to make as many prospective outcomes as commeasurable as possible so that they can be compared directly. For economic consequences, a monetary unit such as dollars is the common measure. We should also try to translate other outcomes which do not initially appear to be economic into monetary unit. For example, the consumptions of electricity. This additional effort towards this goal will enhance commeasurability and make the subsequent analysis of alternatives easier. Principle 5 is consider all relevant criteria. Selections of preferred alternative requires the use of a criterion or several criteria. The decision process should consider the outcomes enumerated in monetary unit and those expressed in some other units of measurement, or made explicitly in descriptive manner. Therefore, in engineering economy analysis, the primary criterion relates to the long-term financial interests of the owners. This is based on the assumptions that available capital will be allocated to provide maximum monetary return to the owners. Often though, there are other organizational or business objectives you would like to achieve with your decision, and this should be considered and given weight in the selections of an alternative. These non-monetary objectives become the basis for additional criteria in the decision-making process. Principle 6. Make uncertainty explicit. The analysis of the alternatives involves projecting or estimating the future outcomes associated with each of them. The magnitude and the impact of future outcomes of any alternative are uncertain. Even if the alternative involves no change from current operations, the probability is high that today's estimates of future cash receipts and expenses will not be what eventually occurs. Thus, dealing with uncertainty is an important aspect. Principle 7. Revisit your decision. A good decision-making process can result in a decision that has an undesirable outcome. Other decisions, even though relatively successful, will have results significantly different from the initial estimates of the outcomes. Learning from experience and adapting based on our experience are essential and are indicators of a good organization. Organizational discipline is needed to ensure that implemented alternatives are routinely post-evaluated and that the results are used to improve future analysis and the quality of decision-making. For example, a common mistake made in the comparison of alternatives is the failure to examine adequately the impact of uncertainty. Only post-evaluations will highlight this type of weakness. Here is an example on how we can apply the 7 principles of engineering economy. The first step of engineering economy analysis is problem definitions. This is important as it provides the basis for the rest of the analysis. The problem is defined here as the government to invest in incinerator. What is incineration? Incineration is a waste treatment process that involves the combustion of organic substances contained in waste materials. It is a type of thermal treatment. Incineration of waste materials converts the waste into ash, flue gas, and heat. Principle 1 is about developing the alternatives. What are the incinerator or incineration technologies or designs that are available? You may come out with several alternatives such as the burn barrel, the moving grate, the fluidized bed, the fixed grate, and the rotary kiln. After coming out with several alternatives of technologies, we can apply Principle 2, which is about focus on the differences in the prospective outcomes of the different alternatives. We can look at what are the differences among these technologies in terms of safety, energy recovery, reductions of solid mass, and efficiency of electric generation. For example, are they safe and allow energy recovery? What is the reductions of solid mass of the original waste? Are they highly efficient technology enables electric generations from recovered heat waste and makes it an efficient measure against greenhouse emission? Then we can look at Principle 3, which is about the use of a consistent viewpoint. In Principle 3, we will decide who will own the facility and who should be the decision maker. What and whose perspective should be adopted in decision making? The public, private sector, or the government? Then we can apply Principle 4, which is about using a common unit of measure. As I mentioned, the most common unit is the amount of money or capital to buy the incinerator. Apart from this, we can also use air quality index to measure the amount of air pollution by the different types of incinerators. Wattage as a measure for energy produced, ton as a measure for remaining mass, and percent as the waste to energy conversions, and etc. Then we proceed to Principle 5, which is to consider all relevant criteria. Here you can select a preferred incinerator using several criteria. For example, based on the amount of waste, the feedstock, air pollution, spaces, underground water contaminations, maintenance, quantity of electric generated, and etc. Principle 6. In Principle 6, we try to make uncertainty explicit. For this, you probably can project the future outcome of each alternative, which means whether we can create a country with much less rubbish, or are we creating more air pollutions by having certain type of incinerators. Okay, in Principle 7, we will revisit the decision. Okay, at this step, you will do post-evaluations to improve future decision-making. A sound engineering economic analysis procedure incorporates the basic principles as shown earlier. Okay, the procedure is presented here in terms of 7 steps. Start off with problem definitions, development of alternatives, development of prospective outcomes, selections of a decision criterion or criteria, followed by analysis and comparison of alternatives, selections of the preferred alternative, and finally performance monitoring and post-evaluations of results. The 7-step procedure is used to assist decision-making within the engineering design process. Now I'm going to show you the general relationship between an engineering design process and how it is related to the engineering economic analysis procedure, the step 1 to step 7 that I've just shown you in previous slide. Okay, this is the engineering design process. Okay, it starts off with the recognitions of a problem to be solved. Okay, we have the step 1 of engineering economic analysis located or present here, where we define the problem to be solved. Okay, the problem must be well understood and stated or defined in an explicit form before project team proceeds with the rest of the analysis. Okay, recognition of the problems is normally stimulated by the need of the internal or external organization. For example, internal need can be an operating problem within a company, whereas an external need can be a customer's expectations about a product or service. Once the problem is recognized, we can formulate the problem to establish the elements of the problem and what constitutes its environment. Finding the possible solutions to the problem can be equated with searching for the potential alternatives and screening them to select a smaller group of feasible alternatives for detailed analysis. It takes creativity and resourcefulness of the team to develop potential alternatives. It takes money to make money, as the old saying goes. There are usually hundreds of opportunities for a company to make money. Engineers are at the very heart of creating value for a firm by turning innovative and creative ideas into new or re-engineered commercial products and services. How can an engineer develop alternatives? What approaches can be used? Classical brainstorming and nominal group technique are the two approaches that have found wide acceptance in industry for developing sound investment alternatives. Classical brainstorming is an approach to find conclusions for a specific problem by gathering a list of ideas spontaneously contributed by each member. The nominal group technique, on the other hand, involves a structured group meeting designed to incorporate individual ideas and judgment into a group consensus. Step 3 involves development of the outcomes and cash flows for each alternative. All monetary transactions, including receipt of revenues and payments to suppliers, creditors, and employees, are cash flow to be considered. Developing the related cash flows for an alternative is estimating what would happen to the revenues and costs if the particular alternative were implemented. In addition to the economic aspect of decision-making, non-monetary factors often play a significant role in the final recommendations. Examples of non-monetary objectives that can be important to an organization include meeting or exceeding customer expectations, safety to employees and to the public, improving employee satisfaction, maintaining production's flexibility to meet changing demands, meeting or exceeding all environmental requirements, and achieving good public relations or being an exemplary member of the community. Step 4 is about selections of a decision criteria. The decision maker will normally select the alternative that will best serve the long-term interests of the owners of the organization. It is also true that the economic decision criterion should reflect a consistent and proper viewpoint throughout an engineering economy study. Step 5 involves analysis and comparison of the alternatives. This is largely based on cash flow estimates for the feasible alternatives selected for detailed study. A substantial effort is normally required to obtain reasonably accurate forecasts of cash flows and other factors such as inflation, exchange rate movements, and regulatory mandates that often occur. Considerations of future uncertainties is an essential part of the engineering economy study. When cash flow and other required estimates are eventually determined, alternatives can be compared based on their differences. Usually, these differences will be quantified in terms of a monetary unit. In step 6, selections of the preferred alternative is simply a result of the total effort from the previous steps. Thus, the soundness of the technical economic modeling and analysis techniques detects the quality of the results obtained and the recommended course of action. As part of the design effort, step 6 is included in the specifications activity of the design process. Step 7 is accomplished during and after we have collected results from the selected alternatives. Monitoring project performance during its operational phase improves the achievement of related goals and objectives and reduces the variability in desired results. Step 7 is also a follow-up step to a previous analysis, comparing actual results achieved with the previously estimated outcomes. The aim is to learn how to do better analysis, and the feedback from post-evaluations is important to the continuing improvement of operations in any organization. Now let's take a look at one example on defining the problem and developing alternatives. The management team of a small furniture manufacturing company is under pressure to increase profitability to get a much-needed loan from the bank to purchase a more modern pattern cutting machine. One proposed solution is to sell waste wood chips and shavings to a local charcoal manufacturer instead of using them to fuel space heaters for the company's office and factory areas. Your task is to define the company's problem. Then next, reformulate the problem in a variety of creative ways. After that, develop at least one potential alternative for your reformulated problem. And don't concern yourself with feasibility at this point. Based on the descriptions, what do you think is the company's problem and how do we reformulate the problem in a variety of ways? The company's problems appears to be that revenues are not sufficiently covering costs. That's why the company is under pressure to increase profitability to get the loan from the bank. Several reformulations can be posed. For example, the problem is to increase revenues while reducing costs. The problem is to maintain revenues while reducing costs. The problem is an accounting system that provides distorted cost information. Or the problem is that the new machine is really not needed, therefore there is no need for a bank loan. After defining the problem, you can develop at least one potential alternative for your reformulated problem. As I mentioned, don't concern yourself with feasibility at this point. Based on reformulation 1, an example alternative is to sell wood chips and shavings as long as increased revenue exceeds extra expenses that may be required to heat the buildings. Another alternative is to discontinue the manufacture of specialty items and concentrate on standardized high-volume products. Yet another alternative is to pool purchasing, accounting, engineering, and other white-collar support services with other small firms in the area by contracting with a local company involved in providing these services. This is another example and is about the applications of engineering economic analysis procedure. A friend of yours bought a small apartment building for $100,000 in a college town. She spent $10,000 of her own money for the building and obtained a mortgage from a local bank for the remaining $90,000. The annual mortgage payment to the bank is $10,500. Your friend also expects that annual maintenance on the building and grounds will be $15,000. There are 4 apartments, 2 bedrooms each in the building that can each be rented for $360 per month. Does your friend has a problem? If so, what is it? A quick set of calculations show that your friend does indeed have a problem. A lot more money is being spent by your friend each year than is being received. The spending is coming from the annual mortgage payment and the annual maintenance cost, which total up to $25,500. This spending is not sufficiently covered up by annual income coming from renting the 4 apartments, as the monthly rent is too low. A 4 here refers to the 4 apartments, $360 here is the monthly rent, and 12 here refers to the number of months per year. And the rent is only giving her $17,280 per year. Okay, we can see that she's losing $8,220 per year by subtracting the income from the expenses. So, what are her alternatives to prevent herself from losing money? Well, we can propose several options to tackle her problem. Let's say we have proposed the following 4 options. Option 1, raise the rent. Option 2, lower maintenance expenses. Option 3, sell the apartment building. Or option 4, abandon the building. Once we have decided on the alternatives, we need to estimate the economic consequences and other required data for each of these alternatives. For option 1, raise the rent. How much raise is needed? We can do a calculations. We can raise the total monthly rent to this amount for the 4 apartments to cover monthly expenses of $2,125. This $1,440 here is the current total monthly rent from the 4 apartments with $360 per month of rent. The R here is the amount of raise. And this $2,125 is the monthly expenses. And we can get these monthly expenses by adding the mortgage payment and maintenance per year and divide this amount by 12 months. And by simple calculations, we can work out the minimum increase in rent, which is $171.25 per apartment per month. As you can see, this is almost a 50% increase in rent. Okay, this increase raises some questions. Will the market bear an increase? Do you think raising the rent by 50% is still easy for your friend to rent out all the apartments? Next, we'll look at the economic consequences of option 2, which is lower the maintenance expenses. We can lower monthly expenses so that these expenses are covered by the monthly revenues of $1,440 per month. This would have to be accomplished primarily by lowering the maintenance cost. There is not much to be done about the annual mortgage cost unless there is a favorable refinancing opportunity. So the monthly maintenance expenses would have to be reduced to $565, and this is obtained by subtracting the monthly mortgage payment from the revenue. And this represents more than 50% decrease in maintenance expenses from $1,250. Then would this decrease cause a safety problem in long term? Option 3 is about selling the apartment building. She can try to sell the apartment building for X dollars, which recovers the original $10,000 investment and recovers the $685 per month loss on the venture during the time it was on. Is this worth for all the works? She went through all the hassle to acquire the apartments, and she's selling just to cover the loss. She might need to further lower the price of the building to quickly sell off the apartments, otherwise more loss may be incurred the longer she waits. Option 4 is about abandoning the building. Your friend can just walk away from the venture and kiss the investment goodbye. But what is the consequence of doing so? The bank will likely assume possession through foreclosure and may try to collect fees from your friend. This option would also be very bad for your friend's reputations and credit rating. After we have analyzed the consequences of each alternative, we can select a criterion for discriminating among alternatives and use it to advise your friends on which course of actions to pursue. One criterion could be to minimize the expected loss of money. In this case, you might advise your friend to pursue option 1, which is to raise the rent, option 2, which is to lower the maintenance expenses, and option 3, which is to sell the apartment building. We can then attempt to analyze and compare the alternatives in view of at least one criterion in addition to cost. Here, for example, we can add creditworthiness as an additional criterion. Option 4, which is abandon the building, is immediately ruled out. Exercising option 3, which is to sell the apartment building, could also harm your friend's credit rating. Thus, option 1 and 2 may be her only realistic and acceptable alternatives. And these options are to raise the rent or to lower the maintenance expenses, respectively. And since there are 2 options left, we can add one more criterion to rule out either one. And let's say we have added the additional criterion, which is not to jeopardize the safety of the apartment in long term, then she is left with option 1. Finally, what should your friend do based on the information you and she have generated? Your friend should probably do a market analysis of comparable housing in the area to see if the rent could be raised according to option 1. Maybe a fresh coat of paint and new carpeting would make the apartments more appealing to prospective renters. If so, the rent can probably be raised while keeping 100% occupancy of the 4 apartments. And this is the final example of today's lecture. Get rid of the old clunker. We consider these situations. Linda and Jerry are faced with a car replacement opportunity where an interest rate can be ignored. Jerry's old clunker that averages 10 miles per gallon of gasoline can be traded in towards a vehicle that gets 15 miles per gallon. Or as an alternative, Linda's 25 miles per gallon car can be traded in toward a new hybrid vehicle that averages 50 miles per gallon. If they drive both cars 12,000 miles per year and their goal is to minimize annual gas consumptions, which car should be replaced, Jerry's or Linda's? They can only afford to upgrade one car at this time. And so in this problem, we are given 2 alternatives to replace Jerry's or Linda's car. We can make a decision by running an engineering economic analysis, which is by calculating the amount of saving when Jerry's or Linda's cars is replaced. Here shows the comparison of the 2 alternatives. By trading in Jerry's old clunker, they can save 400 gallons per year. This is calculated by the difference in the amount of gasoline consumption between the old clunker and the new car. And with similar calculations, we can work out the amount of gasoline saving if trade-in Linda's car instead. This amounts to 240 gallons per year, which is less saving as compared to trading in Jerry's old clunker. And therefore, Jerry should trade in his vehicle to save more gasoline. Okay, that's all I want to talk to you about in this lecture. As a summary, we have learned the basic concepts of engineering economy, the 7 fundamental principles of engineering economy, and how to apply engineering economy analysis procedures. Okay, with this, I'll end the lecture and we'll see you again next week. Bye bye.